Basic concepts of thermodynamics. At the end of this lesson, you will be able to define thermodynamics, explain the microscopic and macroscopic approaches, describe the concept of continuum, system, surroundings and universe, explain thermodynamic equilibrium. Vicky was taught by his professor that according to scientists, thermodynamics and its laws are the tools which literally govern the fate of the universe, and he also added that thermodynamics is a combination of two Greek words, therm and dynamics. Therm means heat and dynamic means motion. So, thermodynamics means motion of heat. But he was still confused and therefore asked a fire about it. "Hey, fire, my professor told me that therm means heat that I can feel near you, but he also said that you can move. How is it possible? See, I can move wherever I want, but how can you move?"
You can move around with the help of your legs. Similarly, my heat energy moved from my source point to that end by the law of heat transfer by conduction, which you cannot see. You can only feel it, did you?
Yes, you are right.
This is what your professor meant when he said that heat could move.
Thermodynamics is a branch of science which deals with relations among heat energy and work done by the heat energy. Let us list some of the applications of thermodynamics. Thermodynamic principle is followed in an internal combustion engine which is used in all kinds of automobiles, steam engines, steam turbines, gas turbines, and for power generation. Now, let us take the power plant as an example to explain various thermodynamic approaches. To generate power, a boiler converts water into steam, which in turn rotates the turbine blade connected to a shaft. This shaft is coupled with a generator shaft to produce electricity. In the boiler, when water is heated, the temperature and pressure will increase. This can be measured by two approaches, microscopic approach and macroscopic approach. Similar to matter, water also has a large number of molecules. While heating, each molecule will have a certain position, velocity and energy for a given instant of time, and as a result of collision, there will be frequent changes in the values of the above variables. Taking the values of each and every single molecule and summing up, these values will give us the exact value of its variables like temperature and pressure. This is called microscopic approach or statistical thermodynamics. It is to be noted that 1 mole will have 6.022 into 10 power 23 molecules. So, it is highly impossible to measure the behavior of every individual molecule. Hence, it will be convenient to study the behavior of many molecules in a matter. For example, pressure and temperature are measured easily with the help of measuring instruments. This is called macroscopic approach or classical thermodynamics. From the atomic nature of substances, we know that atoms in a matter are widely spaced. In macroscopic approach, while considering a volume of molecules at any instant, it will have a specific number of molecules in it. And due to random movement of molecules, it will not be the same in another instance. So, the concept of continuum is used in macroscopic approach of thermodynamics, in which the atoms in a matter are treated as continuous and homogeneous, that is, a continuum. Before heading into the next topic, let us ignite a candle. To know about all these terminologies, a thermodynamic system is a defined space or area in which the transfer of mass or energy or both takes place. Water in the heat exchanger. Lubricating oil in an engine are some examples of a thermodynamic system. Surroundings. Anything outside the system which affects the behavior of a system is called as surroundings or environment. If an air conditioner is a system, then the air in the house and the lawn are the surroundings. System and surroundings are separated by a boundary. It may be fixed or movable and real or imaginary. It will not occupy any volume or mass in space and has zero thickness. System, boundary and surrounding together comprise a universe. Thus, system, surrounding, boundary and universe are the basic concepts of thermodynamics. Let us analyze the working of a car engine to discuss different thermodynamic systems. You are watching the working of an IC engine. The inlet valve opens and air is drawn during the suction stroke. We can see that both the valves are closed during the compression stroke. The piston moves upwards and compresses the air at high pressure and temperature. No mass transfer takes place since all the valves are closed until the piston reaches the top dead center. This is an example of a closed system. Thus, in a closed system, there is no mass transfer, but only energy transfer across the system boundaries. Only heat and work interactions are observed within the system. It is also called control mass system. Open system. After compression and expansion processes, the exhaust valve opens and both mass and energy transfer take place. In an open system, as both mass and energy transfer take place, it is also called control volume process. Thus, the exhaust stroke of an IC engine can be called an open system. Isolated system. A system which is not affected by the surroundings is called an isolated system. Here, no heat, work and mass transfer takes place. For example, when hot milk is poured in a thermoflask, the outer surface is insulated and thus no heat and mass transfer takes place from the flask to the surroundings. We can call this system as an isolated system. Thus, the types of thermodynamic systems are closed system, open system and isolated system. Now, let us discuss about thermal equilibrium. Consider a thermoflask with hot water inside. When its lid is opened, heat transfers from the flask to the surroundings and after some time, the temperatures of this system and the surroundings become uniform. We can say that the system is in thermal equilibrium. When we place two identical objects in a seesaw, and after some time, they will be in a balanced position. Here, there is no unbalanced force in the seesaw. Hence, the seesaw is in mechanical equilibrium. Chemical equilibrium. When a liquid is poured on a ferrous material, due to the electronegativity of the liquid, corrosion occurs and after enough electrons are drawn, it will reach a state where it will lose the tendency to draw electrons from the liquid. Thus, there will not be any chemical reaction within the system. This state is called chemical equilibrium. If a system is in thermal, mechanical and chemical equilibrium, we can say that the system is in thermodynamic equilibrium. Summary. In this lesson, you have learnt about thermodynamics. It is a branch of science which deals with relations among heat energy and the work done by the heat energy. Microscopic approach. If the study of behavior of matter is described by summing up various values of each molecule, it is called microscopic approach or statistical thermodynamics. Macroscopic approach. If the study of behavior of matter is described by the effect of many molecules, it is called macroscopic approach or classical thermodynamics. The concept of continuum. The atoms in a matter are treated as continuous and homogeneous, that is, a continuum. System. the space or area in which the energy transfer and conservation takes place. Surroundings. Anything outside a system that affects the behavior of the system. Boundary. System and surroundings are separated by a boundary. It may be fixed or movable and real or imaginary. Universe. System, boundary and surroundings together comprise a universe. Thermodynamic system. Closed system. In this system, only energy transfer with its surroundings takes place. Open system. In this system, energy and matter transfer takes place with its surroundings. Isolated system. In this system, there is no energy or matter transfer with its surroundings. Thermodynamic equilibrium. It satisfies the following equilibriums. Thermal equilibrium. The temperatures of a system and its surroundings become uniform. Mechanical equilibrium. There is no unbalanced force within a system and between the system and its surroundings. Chemical equilibrium. There is no chemical reaction within the system.